The topic of today's lecture is handling refrigeration equipment that uses flammable refrigerants. In addition, in this lecture we will examine the issues of conversion of the refrigeration equipment that uses halogenated hydrocarbon refrigerants to flammable refrigerants, as well as the requirements for transportation and storage of containers with flammable refrigerants. Only the competent personnel that has passed trainings for handling and is familiar with conditions of use of flammable refrigerants is authorized to handle the refrigeration equipment. All requirements for work with flammable refrigerants, with containers with flammable refrigerants, and with the refrigeration equipment are regulated by the standard EN 378, refrigeration systems and heat pumps, safety and environmental requirements. The personnel should not only be familiar with the standard, but before admission to carrying out works on maintenance and repair of the refrigeration equipment with flammable refrigerants, the personnel should additionally be checked for knowing the requirements of another standard, EN 13313, refrigerating systems and heat pumps, competence of personnel. Any persons who are engaged as extra specialists for carrying out works on maintenance of the refrigeration equipment containing flammable refrigerants can start working with this equipment only in the presence of specialists who have admission to work with the refrigeration equipment with flammable refrigerants. Besides, it should be noted that the personnel should know the legislation and regulations and standards in the field of work with flammable refrigerants. The personnel should know not only the two above-mentioned standards, EN 378 and EN 13313, but also the national regulations and standards for handling combustible substances. In addition, the personnel should know the rules and have practical skills in handling flammable refrigerants, using personal protective equipment, taking measures to prevent the leak of flammable refrigerant from the refrigeration equipment, the rules for handling containers with flammable refrigerants, and also the rules for charging the refrigerant, the rules and regulations for monitoring the leak of the refrigerant, and be familiar with the issues related to the removal and disposal of flammable refrigerants from the refrigeration system. Before starting to work with the refrigeration system, the following procedures must be performed. The working area must be free of combustible materials and sources of ignition. Corresponding firefighting equipment must be available. Before starting to work with the cooling loop or performing welding and soldering, the proper ventilation must be provided in the working area. In addition, the use of such leak detectors and installation of such fixed leak detection equipment, which has explosion-proof design and is equipped with anti-sparkling protection, shall be ensured. If the equipment allows, it is recommended to completely dismantle the entire refrigeration system from the place where it was placed and transport it to the workshop, where repairs can be carried out in compliance with all the necessary safety measures. An example of the arrangement of the workshop with an appropriate ventilation system and detectors is shown on slide 2. Before working with the cooling loop, which is charged with flammable refrigerant, take the following precautions. The refrigerant is removed from the cooling loop to reach the pressure in the loop set by the value of the residual pressure. The loop is purged with inert gas. Nitrogen is most often used for this purpose. Then the loop is vacuumed to the residual pressure of not more than 30 kilopascals. Then the loop is again purged with inert gas, all the same nitrogen. and only after that, the loop is opened for carrying out repairs. When removing the refrigerant from the loop, you need to use the equipment which is designed to work with flammable refrigerants. If national regulations and standards allow the release of the refrigerant into the atmosphere, it is necessary to ensure the safety of such release, using, for example, a flexible hose through which the refrigerant will be released in a safe place. A schematic example of such device for releasing the refrigerant into the atmosphere is shown in slide 3. It should be noted that to the date, there are no requirements in accordance with the standards that would regulate the ban on release of hydrocarbon refrigerants into the atmosphere. These substances are ozone-friendly and have very low global warming potential, so their release to the atmosphere from the point of view of their impact on the climate on a global scale is not limited. The refrigerant should be released into the atmosphere in such a way that under no circumstances should an explosive concentration of the combustible substance be formed with air. There should be no ignition sources near the place where the refrigerants are released. In addition, it is necessary to ensure that during the release of the refrigerant into the atmosphere, there is no possibility of its penetration into the premises. Besides, it is necessary to take into account the fact that the refrigerant dissolves well in the compressor oil. So, when removing the compressor oil from the system, it is required to ensure the absence of dissolved flammable refrigerant in it. After carrying out the repair of the refrigeration equipment, or in the process of routine maintenance, it is necessary to ensure that all plates and inscriptions informing about fire hazard and that are installed on the refrigeration equipment are available and well readable. Also, there are requirements for repair and maintenance of electrical equipment installed in the refrigeration equipment with flammable refrigerants. Before opening the sealed cells, the power supply of the cells must be automatically switched off. If it is not necessary to switch off the relevant electrical equipment during carrying out repairs, continuous monitoring of the refrigerant vapor concentration in the air of the working area should be carried out in order to be able to warn the personnel of potentially dangerous situations. The equipment for monitoring the refrigerant vapor concentration in the air of the working area is calibrated for a specific refrigerant and is set up to give an alarm at the concentration of 20% of the lower flammability limit for particular refrigerant. Every time the repair is completed, the installation and protection of electrical wiring and connections are checked against the requirements of national regulatory documents. Wires and cables are checked for damage. As with any equipment, the operation of the refrigeration unit containing flammable refrigerants is prohibited if a defect is found, and this defect could reduce the reliability of the refrigeration unit or cause a dangerous situation. The only type of electrical equipment permitted for operation in explosive atmosphere is considered to be cells in explosion-proof design. In addition, all cells of electrical equipment and devices of systems and units used for testing refrigeration systems must also be made in explosion-proof design. Slide 4 shows the general procedure for commissioning of the refrigeration systems that use hydrocarbon refrigerants, such as eco-freeze refrigerants. Let's consider this procedure step by step. If you have the equipment that currently uses halogenated hydrocarbons, at the first stage it is necessary to describe all the technical specifications for this equipment. At the next stage, it is required to inspect the refrigeration equipment and estimate its condition. And only at the third stage, it is necessary to calculate the charge of the flammable refrigerant required for this refrigeration equipment and compare it with the maximum possible charge of the flammable refrigerant according to the method described in the previous lecture. If the calculated value of the refrigerant charge fits into the permissible limits, then only at this stage it is possible to proceed to check the condition of all components of the refrigeration equipment. At the fifth stage, it is necessary to assess all the risks associated with the introduction of flammable refrigerants into the refrigeration equipment, as well as to describe all the necessary actions in cases of emergencies. And only after completing these 5 stages, it is possible to carry out in practice conversion of the equipment to the use of flammable refrigerants, that is, recharge the system with the flammable refrigerant. At the next stage, after the refrigeration system is charged with the flammable refrigerant, it is necessary to inspect the absence in the area where the refrigeration equipment is installed of sources of ignition, as well as to monitor the absence of refrigerant leaks from the refrigeration system. And at the last stage, it is necessary to mark the refrigeration system in such a way that third-party people understand that it uses the flammable refrigerant, and to instruct the personnel servicing this refrigeration system. In the process of operation, maintenance, or current repair of the refrigeration equipment, the service staff will always face the possibility of leaks of the refrigerant and the risk that in the process of leaking, fire hazard situation may occur. Slide 5 shows the flow chart of all those situations when the refrigerant may leak and when the staff servicing the refrigeration system must be very attentive. Of course, first of all, the personnel may face the possible leak when the refrigeration system is charged or recharged with the refrigerant. Then it is necessary to comply with all safety requirements and standards. But at the same time, even in the process of the current maintenance and inspection of the refrigeration systems for leaks, it is necessary to take into account the fact of the possibility of an increased concentration of hydrocarbon flammable refrigerants in the air surrounding the refrigeration system. Slide 6 shows the table based on international experience in the use of flammable refrigerants in various types of the refrigeration equipment. The table is obtained not only on the basis of international experience, but also taking into account all the risks for the safe operation of the refrigeration equipment. Here you can see what kind of the refrigeration equipment traditionally uses flammable refrigerants, and in what equipment it is strongly not recommended to use such refrigerants. If we analyze the data presented in this table, it can be seen that in one-piece refrigeration systems, such as household refrigerators, commercial refrigeration chests, or in systems with indirect cooling, When cold from the refrigeration equipment is supplied by intermediate coolant to the cooled object, the use of flammable refrigerants is allowed, permissible, and widely practiced today. There are refrigeration systems in which, for example, the use of such refrigerants is not recommended but possible. It is likely that over time, in the process of developing new safety standards due to strengthening of environmental safety requirements, such equipment will also gradually switch to the use of flammable refrigerants. For example, today the use of flammable refrigerants is allowed only in cars to ensure comfortable conditions for passengers. However, the use of flammable refrigerants is questionable in case of ensuring comfortable conditions for passengers in bus and rail transport. It is likely that with the change of standards it will be allowed later. A complete ban on the use of flammable refrigerant currently exists only in the aviation. In the next slide, we will consider the procedure for switching to the use of the flammable refrigerant in a household air conditioner consisting of two units, indoor and outdoor, in the so-called split air conditioner. Consistently consider all the steps associated with safety when converting this conditioner to the flammable refrigerant. As an example, we will consider the option. The air conditioner initially used the refrigerant R22, and the mass of the refrigerant charge was 1.3 kg. If it is necessary to convert the air conditioner to the use of the flammable refrigerant, at the first stage, the type of the refrigerant used in this equipment and its charge size should be checked. This information is given in the plate located on the indoor or outdoor unit of the air conditioner, as shown on slide 7. In this example, after determining the mass of the refrigerant charged to the air conditioner, it is necessary to estimate the coefficient that takes into account the fact that the mass of the hydrocarbon refrigerant will be less than the mass of the hydrofluorocarbon refrigerant charged into the system. The conversion factor can be found in the table presented further, or it can be checked according to the refrigerant supplier's data. Typically, the mass of the hydrocarbon refrigerant charged into the system is 50% less than the mass of the hydrofluorocarbon refrigerant. That is explained by difference in the density of these substances. In this case, according to the table available to us, when switching from the use of the refrigerant R22 to the refrigerant R290, that is propane, the size of charge with propane should be 42% of the size of charge with the refrigerant R22. Thus, the mass of the hydrocarbon refrigerant charged to our air conditioner will be 540 grams. At the next stage, it is necessary to check whether such mass of the refrigerant charged falls within the maximum possible charge size. The maximum allowed mass of the refrigerant for this equipment, taking into account its location and field of application. As mentioned in the previous lecture, For split air conditioning, we consider separately the indoor unit, located in the room, and the outdoor unit, located most often on the street and usually in well-ventilated area. For indoor and outdoor units, the categories are defined separately, according to the requirements of the standard. Since the outdoor unit is located on the street, not in the industrial area, and people have no free access to it, this unit of the refrigeration equipment is classified as category C, and therefore there are no requirements limiting the mass of the refrigerant charged to the system for such equipment. Additionally, the maximum size of the charge is calculated for the indoor unit located in the office space. Since the indoor unit is located in the office space, it is classified as category B, and the maximum size of the charge and its calculation are shown on slide 7 and correspond to the example discussed in the previous lecture. In our case, it is 560 grams of the refrigerant, and that is slightly higher than the required 540 grams of the refrigerant for the complete charge of our air conditioner. Therefore, we have a principal opportunity to switch the air conditioner to the new refrigerant propane. After estimating the possibility of changing the refrigerant, it is possible to proceed with the technical implementation of the operation of converting to the use of the flammable refrigerant. Slide 8 shows the next steps in this procedure. It is necessary to check, first of all, the availability of the required equipment and ensure the safety of the space in which the air conditioner is located. In addition, it is necessary to provide free access to all connections of the cooling loop in order to monitor possible leaks of the refrigerant during its charging. A very important requirement is removal from the area of all possible sources of ignition, including even cell phones, although today there are no clear proofs that they can be sources of ignition, and electrical appliances that are not in explosion-proof design should not be in the area where the air conditioner will be charged with the flammable refrigerant. The following steps for charging the air conditioner are presented on slide 9. When converting the air conditioner to the use of the flammable refrigerants, the installation of emergency ventilation and alarm systems is not required. And only after all the steps described above, it is possible to proceed with the conversion from the old refrigerant R22 to the flammable refrigerant propane and recharging the system with new refrigerant. After this operation, it is necessary to ensure the availability of all documents and to mark the system and check further for the leaks in cooling loop. And only after that we can assume that the conversion of the equipment to the use of the flammable refrigerants is carried out in accordance with all safety requirements. Slide 10 provides the information on methods for detecting hydrocarbon refrigerant leaks. It should be noted that the traditionally used soap bubble leak test in the air for the flammable refrigerants is not recommended. Soap bubble leak test can only be used to detect leaks if the system is filled with a medium that doesn't contain oxygen, for example with nitrogen. To detect leaks, it is recommended to use special detectors designed for detecting leaks of hydrocarbon refrigerants. It is also necessary to focus on the storage of containers with the flammable refrigerants. First of all, they are subject to the same requirements as the storage of containers with hydrofluorocarbon refrigerants, and to the additional requirements that are usually prescribed by national standards. But nevertheless, now I will tell you the basic requirements that are usually the same regardless of the country in which containers with hydrocarbon refrigerants are transported and stored. Cylinders with the refrigerants should be stored in specially designated areas in dry, well-ventilated premises, preferably outdoors under an awning. No sources of ignition should be available nearby. Access to the storage area is allowed only to the authorized persons who have admission for handling the flammable hydrocarbon refrigerants. The storage areas of hydrocarbon refrigerants should be marked with inscriptions prohibiting smoking and use of open fire. The storage area must be at the ground level. Storage in basements or premises below the ground level is prohibited. The approach to the containers in which the refrigerants are stored should be easily accessible. Storage of containers with the flammable refrigerants in the residential areas is prohibited. All containers with the refrigerants should be stored in upright position only. In addition, the standards of different countries specify the maximum mass of the flammable refrigerants that can be stored simultaneously in one warehouse. These requirements need to be checked in the standards of the relevant country. For example, in the United Kingdom, this mass is limited to 70 kilos of the refrigerant in one place. Slide 12 shows the requirements for transportation of the flammable hydrocarbon refrigerants in containers and cylinders. Usually, the requirements for transportation of containers with such refrigerants meet the requirements for transportation of containers with propane-butane. Further, I will list the basic requirements which are actually standard and applicable to almost all countries. The first requirement: a carrier must have written information about the substances transported. This information should be available in emergency situations and should be well visible. The information on the combustible substances to be transported must correspond to the cargo size on the vehicle. The carrier must know and understand the hazards and emergency procedures for handling combustible substances. A vehicle shall be equipped with a dry powder fire extinguisher of at least 2 kg capacity, and the driver of the vehicle shall be trained in the use of this fire extinguisher in cases of emergencies. Containers with refrigerants should be placed in a strictly upright position, so that the valves are at the top and the cylinders shall be securely fastened. Proper ventilation should be provided in a car or other vehicle used for transportation of containers with the refrigerants. That is, not all vehicles can be suitable for transportation of the flammable refrigerants. A warning sign shall be placed on the rear of the vehicle indicating that dangerous combustible substances are being carried. Smoking and the presence of sources of open fire are prohibited inside the vehicle. In addition, it is necessary to focus separately on the disposal of the flammable refrigerants. The slide shows an example to be taken into account if the flammable refrigerant is not released into the atmosphere, but is charged into the used cylinder for the refrigerants. Typically, the mass of the refrigerants that could be filled in a standard cylinder for hydrocarbon refrigerants is approximately 2 times less than for hydrochlorofluorocarbons. This is explained by the difference in density of these substances. For a very rough estimate, it is possible to calculate the mass of the refrigerants that can be filled into a standard cylinder used for hydrochlorofluorocarbon refrigerant by multiplying the initial mass of the refrigerant in this cylinder by a factor of 0.4. It means that the mass of hydrocarbon refrigerant charged into the cylinder should be approximately 40% by mass of halogenated hydrocarbon refrigerants for which this cylinder is designed. More accurate coefficients for the conversion of the mass of the hydrocarbon refrigerant and the mass of the hydrofluorocarbon refrigerant. This is the same coefficient that was used in calculation for the mass of recharge, as shown on slide 14. As can be seen from this slide, depending on the type of the hydrofluorocarbon refrigerant and to which hydrocarbon refrigerant the refrigeration equipment is converted to, the mass may be 50 or 40% of the initial charge of the hydrofluorocarbon refrigerant. Here are the approximate values that are estimated according to the difference in density of these refrigerants. It should be borne in mind that the charge size will also depend on the parameters of the refrigeration equipment. This fact is not so substantial as the significant change in the density of hydrocarbon refrigerants compared to the halogenated refrigerants. The basic information used to prepare this lecture is available on slide 15. Thank you for your attention.